Hi folks, welcome to 6.2 and we're going to talk about the disc and washer method here. So right now we're going to take a look at question number 1. And for all of these questions, you'll notice that I have the question, a graph, a space for us to draw a diagram, and then a space for us to do the integral, okay? I think it's really important that you know how to draw the diagram that goes with it to help you understand the process. So let's get started. Number 1 says find the volume of the solid of revolution generated by rotating the graph of f of x equals the square root of x over the interval 0 to 4 around the x-axis. Okay, so let's start with the graph. I'm going to go ahead and graph the function f of x equals the square root of x. And I can do that either by knowing the graph, the parent function graph, or I can plug in some points. So if I plug in 0 for x, I will get 0 for y. If I plug in 1 for x, I will get 1 for my y value. And then if I plug in 4 for x, I will get a 2 for my y value. And that will give me a sketch of the graph for f of x. Okay, now let's take the region that we're interested in. So I'm going to be starting at 0 and stopping at 4. Okay. Now, where am I revolving it around? I am revolving it around the x-axis. So this is my axis of revolution. Sometimes we just say AOR for axis of revolution. Another name for this axis of revolution is y equals 0. Okay? All right. So you might notice that we have our graph here, and it seems like there's a whole bottom half of the graph that I haven't used yet. Now that's on purpose because what I want us to do is we're going to draw the reflection. What would happen if we revolved it and then we cut it in half so we could see half of our shape? And when we revolve it, we'll end up with points that are symmetric around that axis of revolution. So 0, 0 is going to stay. It'll be 1, -1, and 4, -2. And if I connect those lines, or those dots rather, this is the reflection of what I've revolved, okay? All right, so now when we're revolving things, everything turns out to be a circle. Like the cross section is going to be a circle. And so what we need to do now is think about what a cross section would look like. So a cross section is just going to be from, let's say, here to here, okay? And that line that we have here represents the diameter of the circle, okay? Now, because I'm usually using circles, and I know that the area formula for a circle is pi r squared, usually we don't draw the whole thing, we actually just draw the radius. So I'm going to undo this, and I want us to draw in some sample radii. So a radius could be from here to here. There would be one circle. If I revolve that blue line around, I will get a circle. This could be another radius of another circle. This could be another radius of a circle, and then I would have a radius of a circle all the way out here. And I would have an infinite number of these radii going between 0 and 4. Okay, so that's what we're looking at. Now I'm going to go ahead and draw a cross section too. So I know that I'm looking at slices that are circles, okay? And I know that the radius of this circle is going to be those blue lines that I drew. And I know that the area for a circle is pi r squared. Okay. So let's go ahead and set up our integral. So the volume is going to equal the integral of pi r squared. Now, is it going to be dx or dy? Well, my blue lines are perpendicular to my axis of revolution, or I'm stacking them along the x-axis, so it's going to be dx. That means I can put a and b in for my bounds. All right, let's fill in the information we have. I'm going to bring the pi out to the front because it's a constant. My smallest radius is at 0, and my ending radius is at 4. Okay. So again, I'm finishing here at 4. Now, the radius of this function is the blue one, and the radius is defined by my curve, f of x. And so I'm going to put in square root of x is going to be the function for the radius. So that is the radius, and I need to square it. All right, let's simplify. Pi, the integral from 0 to 4 of x dx. Okay, let's integrate 1/2 x squared. Don't forget your pi, and you're going to draw a line, put a 4, put a 0. All right, we've got pi over 2 times 4 squared minus pi over 2 times 0 squared. Now this second term is going to go to 0. So I can find a final answer of 16 pi over 8, or over 2 rather, or when I simplify, a final answer of pi times 8, or 8 pi. And so when I revolve this curve of square root of x from 0 to 4 around the x-axis, the volume of that shape will be 8 pi. All right, so that's it for question number 1. Come on back for question number 2. We've got a total of 10 practice questions to go over. All right, see you back here.